Problem solving. In previous math courses, you've no doubt run into the infamous word problems. Unfortunately, these problems rarely resemble the types of problems we actually encounter in everyday life. In math books, you usually are told exactly which formula or procedure to use and are given exactly the information you need to answer the question. In real life, problem solving requires identifying an appropriate formula or procedure and determining what information you will need and won't need to answer the question. In this chapter, we will review several basic but powerful algebraic ideas: percents, rates, and proportions. We will then focus on the problem-solving process and explore how to use these ideas to solve problems where we don't have perfect information. Percents. In the 2004 vice presidential debates, Edwards claimed that U.S. forces have suffered 90% of the coalition casualties in Iraq. Cheney disputed this, saying that in fact, Iraqi security forces and coalition allies have taken almost 50% of the casualties. Who is correct? How can we make sense of these numbers? Percent literally means per 100 or parts per 100. When we write 40%, this is equivalent to the fraction 40 over 100, or the decimal 0.40. Notice that 80 out of 200 and 10 out of 25 are also 40%, since 80 divided by 200 equals 10 25ths equals 40 divided by 100. Example 1. 243 people out of 400 state that they like dogs. What percent is this? 243 divided by 400 equals 0.6075 equals 60.75 divided by 100. This is 60.75%. Notice that the percent can be found from the equivalent decimal by moving the decimal point 2 places to the right. Example 2. Write each as a percent. A, 1/4. B, 0.02. C, 2.35. A, 1/4 equals 0.25 equals 25%. B, 0.02 equals 2%. C, 2.35 equals 235%. Percents. If we have a part that is some percent of a whole, then percent equals part divided by whole, or equivalently, part equals percent multiplied by whole. To do the calculations, we write the percent as a decimal. Example 3. The sales tax in a town is 9.4%. How much tax will you pay on a $140 purchase? Here, $140 is the whole, and we want to find 9.4% of $140. We start by writing the percent as a decimal by moving the decimal point 2 places to the left, which is equivalent to dividing by 100. We can then compute tax equals 0.094 multiplied by 140 equals $13.16 in tax. Example 4. In the news, you hear tuition is expected to increase by 7% next year. If tuition this year was $1,200 per quarter, what will it be next year? The tuition next year will be the current tuition plus an additional 7%. So it will be 107% of this year's tuition. $1,200 multiplied by 1.07 equals $1,284. Alternatively, we could have first calculated 7% of $1,200. $1,200 multiplied by 0.07 equals $84. Notice this is not the expected tuition for next year. We could only wish. Instead, this is the expected increase. So to calculate the expected tuition, we'll need to add this change to the previous year's tuition. $1,200 plus $84 equals $1,284. Try it now. A TV originally priced at $799 is on sale for 30% off. There is then a 9.2% sales tax. Find the price after including the discount and sales tax. Example 5. The value of a car dropped from $7,400 to $6,800 over the last year. What percent decrease is this? To compute the percent change, we first need to find the dollar value change. $6,800 minus $7,400 equals negative $600. Often, we will take the absolute value of this amount, which is called the absolute change. The absolute value of negative 600 equals 600. Since we are computing the decrease relative to the starting value, we compute this percent as $7,400. 600 divided by 7,400 equals 0.081 equals 8.1% decrease. This is called a relative change. Absolute and relative change. Given two quantities, absolute change equals the absolute value of ending quantity minus starting quantity. Relative change is the absolute change divided by the starting quantity. Absolute change has the same units as the original quantity. Relative change gives a percent change. The starting quantity is called the base of the percent change. The base of a percent is very important. For example, while Nixon was president, it was argued that marijuana was a gateway drug, claiming that 80% of marijuana smokers went on to use harder drugs like cocaine. The problem is, this isn't true. The true claim is that 80% of harder drug users first smoked marijuana. The difference is one of base. 80% of marijuana smokers using hard drugs versus 80% of hard drug users having smoked marijuana. These numbers are not equivalent. As it turns out, only 1 in 2,400 marijuana users actually go on to use harder drugs. Example 6. There are about 75 QFC supermarkets in the U.S. Albertsons has about 215 stores. Compare the size of the two companies. When we make comparisons, we must ask first whether an absolute or relative comparison. The absolute difference is 215 minus 75 equals 140. From this, we could say Albertsons has 140 more stores than QFC. However, if you wrote this in an article or paper, that number does not mean much. The relative difference may be more meaningful. There are two different relative changes we could calculate, depending on which store we use as the base. Using QFC as the base, 140 divided by 75 equals 1.867. This tells us Albertsons is 186.7% larger than QFC. Using Albertsons as the base, 140 divided by 215 equals 0.651. This tells us QFC is 65.1% smaller than Albertsons. Notice both of these are showing percent differences. We could also calculate the size of Albertsons relative to QFC. 215 divided by 75 equals 2.867, which tells us Albertsons is 2.867 times the size of QFC. Likewise, we could calculate the size of QFC relative to Albertsons. 75 divided by 215 equals 0.349, which tells us that QFC is 34.9% of the size of Albertsons. Example 7. Suppose a stock drops in value by 60% one week, then increases in value the next week by 75%. Is the value higher or lower than where it started? To answer this question, suppose the value started at $100. After 1 week, the value dropped by 60%. $100 minus 100 multiplied by 0.60 equals $100 minus $60 equals $40. In the next week, notice that the base of the percent has changed to the new value, $40, computing the 75% increase. $40 plus $40 multiplied by 0.75 equals $40 plus $30 equals $70. In the end, the stock is still $30 lower, or $30 divided by $100 equals 30% lower value than it started. Try it now too. The U.S. federal debt at the end of 2001 was $5.77 trillion, and it grew to $6.20 trillion by the end of 2002. At the end of 2005, it was $7.91 trillion and grew to $8.45 trillion by the end of 2006. Calculate the absolute and relative increase for 2001 through 2002 and 2005 through 2006. Which year saw a larger increase in federal debt? Example 8. A Seattle Times article on high school graduation rates reported the number of schools graduating 60% or fewer students in 4 years, sometimes referred to as dropout factories, decreased by 17 during that time period. The number of kids attending schools with such low graduation rates was cut in half. A. Is the decreased by 17 number a useful comparison? B. Considering the last sentence, can we conclude the number of dropout factories was originally 34? A. This number is hard to evaluate since we have no basis for judging whether this is a larger or small change. If the number of dropout factories dropped from 20 to 3, that'd be a very significant change, but if the number dropped from 217 to 200, that'd be less of an improvement. B. The last sentence provides relative change, which puts the first sentence in perspective. We can estimate that the number of dropout factories was probably previously around 34. However, it's possible that students simply moved schools rather than the school improving, so that estimate might not fully be accurate. Example 9. In the 2004 vice presidential debates, Edwards claimed that U.S. forces have suffered 90% of the coalition casualties in Iraq. Cheney disputed this, saying that in fact, Iraqi security forces and coalition allies have taken almost 50% of the casualties. Who is correct? Without more information, it is hard for us to judge who is correct, but we can easily conclude that these 2% are talking about different things, so one does not necessarily contradict the other. Edwards' claim was a percent with coalition forces as the base of the percent, while Cheney's claim was a percent with both coalition and Iraqi security forces as the base of the percent. It turns out both statistics are in fact fairly accurate. Try it now 3. In the 2012 presidential elections, one candidate argued that the president's plan will cut $716 billion from Medicare, leading to fewer services for seniors, while the other candidate rebutes that our plan does not cut current spending and actually expands benefits for seniors while implementing cost-saving measures. Are these claims in conflict, in agreement, or not comparable because they're talking about different things? We'll wrap up our review of percents with a couple of cautions. First, when talking about a change of quantities that are already measured in percents, we have to be careful in how we describe the change. Example 10. A politician's support increases from 40% of voters to 50% of voters. Describe the change. We could describe this using an absolute change. The absolute value of 50% minus 40% equals 10%. Notice that since the original quantities were percents, this change also has the units of percent. In this case, it is best to describe this as an increase of 10 percentage points. In contrast, we could compute the percentage change. 10% divided by 40% equals 0.25 equals 25% increase. This is the relative change, and we'd say the politician's support has increased by 25%. Lastly, a caution against averaging percents. Example 11. A basketball player scores on 40% of 2-point field goal attempts and on 30% of 3-point of field goal attempts. Find the player's overall field goal percentage. It is very tempting to average these values and claim the overall average is 35%, but this is likely not correct, since most players make many more 2-point attempts than 3-point attempts. We don't actually have enough information to answer the question. Suppose the player attempted 200 2-point field goals and 100 3-point field goals. Then they made 200 multiplied by 0.40 equals 80 2-point shots, and 100 multiplied by 0.30 equals 30 3-point shots. Overall, they made 110 shots out of 300 for a 110 divided by 300 equals 0.367 equals 36.7% overall field goal percentage.